our second day of DecisionCAMP, and our first presenter today is Jan Vanthienen, who is commonly known as the decision table professor from Belgium. And it's hard to find anybody who contributed more than Jan to the design, theory, and practice of decision management in general, and in constructions of decision tables in particular. And today, Jan will address the question, you built a decision table, a decision model. Now what? So, Jan, tell us about now what.
Okay, thank you, Jacob. Good morning to you all in the States, and good afternoon to our Europeans. The topic of the talk, and for once I have less than 20 slides. It doesn't happen too much, but the topic of the talk is assume you can build a decision model. And I say assume because it's not always that easy, but once you have done it, now what? What can you do with it? That's the topic for today. I am Jan Vanthienen indeed, as Jacob was telling. I'm still researching at the University of Leuven, less teaching, which gives me more time for research, that's fine. And yeah, I think most of you will know me, so I'm in this area of decision models and rules and processes and information systems. And I am in the Faculty of Economics and Business, dealing with information systems, or in an information systems group. All right. So when you build the decision model, that was too soon. Assuming you can build one. Sometimes it's not finished. Sometimes you only have a list of decisions. That's even useful. Sometimes you only have a decision requirements diagram, but not the logic yet. That's already fine, but it's not complete, I would say. But you can still do some interesting thing with it. I refer you to the on-ramp group, which is thinking about these issues also, but I assume here you have built a decision model, you have your requirements diagram, you have some logic, of course, preferably in the form of a decision table. You might even have some feel to make everything executable, but you have a decision model. What can you do with it? Of course, the first purpose, or everyone thinks this is the first purpose, is to make a decision. And I want to take you on a small tour in this session that you can do more than make a decision. You can try to explain or to understand the model, to evaluate the model, to check it, to analyze it, to get some insight, some knowledge from the model. And when you're executing, you can monitor, you can try to predict, you can do many other things than just this one element, make a decision. That's the point I would like to make. And let's go over these elements one by one. First, assume you have an executable decision model. You have for DRD, you have some tables, maybe some field expressions, but it's fully executable. What can you do with it? Well, the first thing you can do, I hope you can see the mouse moving. Yeah, the first thing you can do is you just take a case, you have all the data available, and you make a decision with all these inputs available. This is the standard way of using a decision model to make a decision. It's not the only way. You can also do this in a more optimal way, meaning you only ask relevant questions or you look up relevant data. I have the impression sometimes we seem to forget this in execution. Suppose you have a small decision table here, or a small decision model, which is basically the same, with a number of rules in rows. So if you are, for instance, between 25 and 60, or if the applicant is between 25 and 60, then the medical history is not important. It doesn't matter, a dash. Then the risk rating for this applicant is medium. If you are executing this decision model for an applicant of age 25 to 60, You don't need the medical history. You don't have to look it up. You don't have to ask it. You don't have to do a database access or whatever. You can simply skip it. And I still have the impression that in some tools, you need all the data first, and they need to be available. Well, available, in my mind, means you can have the value if you want it, but sometimes you don't even need it. You don't want it. Just like in this DRD here, the applicant risk rating depends on input element H, information item, and another decision, medical history. But of course, not in all cases. In our case of 25 to 60, the medical history is not relevant. You don't have to look it up. You don't have to execute this decision. You don't even have to retrieve the data and so on. Relevant information items or irrelevant dependencies in this case, only in this case, otherwise I wouldn't have it in my picture, can be skipped. So in executing a decision, that's one small point I would like to make, a small optimization.
Jan, may I ask you a question? It's
Yes.
really very important thing what you just brought. Irrelevant information, how to define irrelevance. As a humans, we all understand you, but do you think it should be feature of product to define this irrelevance, or it should be customer who will validate that medical history is present only in case when it's needed?
You can, there are multiple levels there. Here it's in a rule or in one of the rows of my decision table. So the medical history is irrelevant in case the applicant age is between 25 and 60. It doesn't mean that's irrelevant in other cases. This, of course, is under the assumption that I start with applicant age. If I would start with medical history, the situation is different. So given a certain order of conditions, some of them might be contracted into irrelevant. You might even go further and look for the most or the shortest way to represent your logic by playing with the columns and so on, but that would be more advanced. But the simple thing that if you have a number of rows in the decision table and in one of the rows a value of an information item is not relevant, then you don't have to look it up, you don't have to ask it. And this is particularly important in dialogues. You don't have to ask 100 questions to the user in a chatbot, for instance, if you only need 10 input values.
Yeah, but majority of tools today cannot define
well,
this
that's
irrelevance,
what I
right?
assumed. Yes.
That's your point, right?
Yeah, and I think you should.
We should walk tougher.
It's so obvious you should skip that.
I see.
You might say it's not important. I have the data available anyway. Yes, but if it's a complex database lookup, you don't have to do it because
it's
you
a serious requirement. Thank you.
All right. So that's the first item, making a decision. That's the major objective of building your decision model and then working with it. But there are many others. And the second one, I would say, is you don't always want to go to the final decision. Sometimes it's enough to say, okay, I have a decision model. I illustrate it with a decision table, but it can be a model. I don't need an exact answer. I'm satisfied with just a range of answers. For instance, I am having a decision model on tax, whatever things I have to pay. Maybe it's enough if I know a bracket or a range. I have to pay between this and this amount, and I don't care about the details. And that's what I want to illustrate in this small table here. Remember that in DMN, you can also have rules in columns. I want to stress it because I don't see all the vendors doing this. So here in this red ellipse, if your age is between 45 and 60, and the years of service is less than 15 or between 15 and 30, so less than 30 actually, then your famous holidays, because this is the holidays example, is 22 plus 2, which is 24 days. If on the other hand, you're older than 30 in the same age category, you have 22 plus 5 plus 3 is 30 holidays. So what can I say without looking at all the input information items? Suppose I only know that the age of my employee is between 45 and 60. I don't have access to service information, or I don't want to give it. It's unknown, whatever reason. What can I already conclude? Well, the number of holidays will be either 24 or 30. So I can tell him or her that he or she will receive 24 to 30 holidays, somewhere in between, not 23 and not more. So with partial information, I can already have some results. It's not an exact result, but it's a range. And that can be important in advisory applications. Someone calls you and says, if I will come and work for your company, what would be my salary? Maybe you cannot say, sorry. Maybe you cannot say an exact amount, but you can say it's between 4,000 and 4,400, whatever currency. Maybe that's enough. Maybe the person doesn't want to give more information. We can do it with the same decision model by looking at what are all the possible conclusions for my input case with this limited amount of information. It's simple. It's the same model, but we don't go all the way and we don't ask or retrieve all the input data. It's something we can do once we have a decision model. If you don't agree, just interrupt me. Yeah. Third thing, and I talked about it last year at DecisionCAMP and also at RuleML, some more flexible reasoning. If you have some input data, you can make a decision. Then you can change one of the input data and ask, what if I would change this value? What is the result now? It's like a simulation. Or you can say, I have a number of input information items, I have my data, I reach a conclusion. How did I get this conclusion? Or how do I get to a certain conclusion? To allow some more flexible reasoning by switching off or changing some of the input values. Of course, this requires some kind of user interface where you can say, I want to change the value of that information item. In one of the talks yesterday, there was a question about this, or there was it was a feature in one of the talks. It's the same decision model, but now you play with the input data and you rerun the model for other or slightly different input data. Given some information items or given an obtained outcome, use the same reasoning mechanism for other forms of inferencing. What if, how do I get there? Why did I get there? Simulate with input data and so on, which can be very interesting. The decision model is the same. You still have your model, your DRD, your logic, and some feel in some cases if this is necessary, but with exactly the same model, you can ask other questions. And remember last year, we added a chatbot to ask these questions, where we use exactly the same one and only decision model, and we communicate with the user, or the chatbot communicates with the user, where the user can now ask questions. How, why, what if, I would like to change this, what would be the result? And then on top of this advanced reasoning mechanism, you put some natural language interface and you have chatbot. And the interesting thing is that this chatbot is a no-code chatbot. Yesterday we had a lot of talk about no-code. This is perfectly no-code. For a given decision model, the chatbot can interact with the user. If you put in another decision model, you have another chatbot. So there's no need to build chatbots for every specific problem, because that's what we see nowadays. Very complicated efforts for simple chatbots. You can build one generic chatbot for DMN. That's what we illustrated last year. And then have some basic questions, even with natural language. which is an interesting suggestion. I'm not saying this is the perfect product, but at least this is an interesting question. No code whatsoever. And it solves a problem, because in every information system, whenever we build an information system to make a decision or to do a transaction, you always have customers calling with lots of questions. Why do you charge me this? How do I do that? Why do you that? What if? These are the typical questions. And in automation, we forgot about these questions, and we set up help desks and call desks, and we never have enough people and enough money to man the call desks. Well, we should automate the call desks, not with stupid chatbots, but with intelligent chatbots, for instance, for DMN. I give it as a suggestion. It will solve this hidden service problem, and it makes decisions explainable. Remember yesterday, Alan, I think, was talking about there should be a dialogue for explanation. Well, this is a dialogue. The customer starts the dialogue, asks a question, gets the results, asks a new question, and so on. This is an explaining or explanation dialogue based on a decision model.
Jan, can I interrupt you
Yes.
again? Sorry. This is so important what you're talking about, and especially in the light what Alan presented yesterday, this conversational explanation screen. How we do this these days? We believe that this is a business logic, and if let's say years of service are not defined, so we put special, like in DMN, we can write if years of service is null, then do something. If it's not null, then do something else. So we force our users to provide this logic. What, if I hear you correctly, you're saying that the same model should be smart enough. We can use the same business model created by business people, but our decision engine should be smart enough to decide to add this logic internally. If it's defined or if it's not defined, then automatically expand this model in this direction.
Actually,
this is your suggestion?
Yeah, actually, in the world of expert systems and knowledge-based systems, we have been doing this for years.
Yes,
if some data is not available, you reason in another way. But since DMN, we seem to fix our reasoning in terms of, given all the input data, go straight to the decision model, up to the decision, which is not necessarily true. You can reason in multiple directions. Then, of course, your model has to be fine, perfect. You cannot leave it open and so on. So that's why I'm not saying this is the perfect solution yet. You need a perfect model. And it doesn't go as far as what Alan was telling about yesterday. This is not a full dialogue with the customer about the risk and all these things. This is a simple dialogue on one decision model about the questions and the information items and the results of the model. So it doesn't go that far, but at least it gives an idea. For instance, on the left here, we simulated it on a phone. I receive a certain outcome in a decision model, then the user can ask, why did I receive this premium or salary or whatever? And then the line of reasoning comes back, and then the user can say, what if I change one of my inputs? And then, of course, you have to say which input and the new value. So you can play with the decision model. We built another chatbot this year. It's not finished yet, but it's ongoing work where this is pluggable on any website, any web page. It's one line of code. You use this small app, you plug it on a website, and you have the dialogue on the decision model on this website. So I'm an academic, I'm not a vendor. So I just want to point out some directions. Maybe we should do more with our decision models, our DMN models, than just here are all the inputs, give me one output. That's, of course, one important thing, but that's not everything we want to do. We want to play with the model. We want the user to interact with the model and get rid of all these questions to our service desks and call desks and very expensive people. They can look it up themselves. Of course, they can look at the DMN model, but that's not what they will do. But if they can chat with a model, maybe that's an interesting direction. Okay, the presentation, you can find it in last year's DecisionCAMP, which is still available. Next point, we have the model. We allow to explain about the model and to communicate the model. Next thing we can do, not necessarily in this order, is make sure the model is correct. Evaluate the quality and complexity. If you know me, you know I've been doing this for a few decades. Checking model consistency, readability, interoperability, improve the model, improve the decision tables, reorganize the decision tables, all those things. And also this is from one of the earlier DecisionCAMPs. Just like we talk about information quality, we should talk about decision model quality, with elements like intrinsic quality, contextual quality, representational quality. Look at the terms in red here. These are things we know we do. If you build the decision model well, if you use some good methodology, you have a nice decision model with all these nice properties. But we should pay attention to it. It's not because you have a model that produces the correct result that it's a nice model. The quality should be high, the consistency should be there, it should not be too complex, and so on and so on. For instance, I think 2 years ago at DecisionCAMP, we had a small presentation on model complexity. How do you judge, how do you evaluate if one model is more complex than another model? Just like how do you evaluate program complexity? And there are metrics for this. Number of decisions, number of elements, number of arrows, all these things. We could start using it. Or another item, consistency. You know, I'm a big fan of consistency. And we know from decision table methodology that the best way to obtain a correct model is to make it very hard to build an incorrect model. What we often do, I mean in the community, is first build the model and then check it. I don't think it's the correct approach. We should build the model in such a way that it cannot go wrong. And that's why I'm so much in favor of avoiding redundancy in a model and in a table. That's why I'm so much in favor of unique hit tables. All the other tables have redundancy or are hard to explain, hard to interpret, and therefore are not consistent by design. I think it's important. We should avoid all this redundancy. Maybe it's a little larger, maybe we have few more rules, but it pays off in the end. That's one of the elements of quality. That's what we can do once we have our decision table and decision model. Make sure it is of high quality. Next topic. We have a decision model and we have been using it. It's fine. I illustrate it with tables because it's simple and easy to view. We can check if the decision model is compliant with some rules and regulations. And the way I say it, and Ron will understand me, the decision model here or the table is not a rule. There might be other rules. For instance, there might be a rule in my silly holiday example that somewhere said the number of holidays can never be larger than 30. Okay, that's something I keep in the back of my mind. I build up my decision table, and suppose this rule is not in my decision table, I can still use it to check that for every column in my decision table, for every case, I still obey the rule that the number of holidays is never larger than 30. Here it is 27, 22, 24, and so on, but I never go beyond 30. In the last case, it's 30 and 30. So should this be in the table? Well, maybe in another way. Should I check it early? Should I do something? What I'm saying is, whatever you do, at least if you have a model, you can check if it's compliant with some other rules. or rules from another source. You can first build the model and then check if it is still compliant, or you can build the model and make sure it is always compliant while you are building it. But whatever way you tackle this, you can check if your model is compliant with some existing rules and regulations. That's also a quality issue. Next point. You can examine if the model is fair or justifiable, or whatever you call it. I'm not saying these are synonyms, but I don't know the exact definitions, but let me give you a small example. If you are going for a loan in a bank, all other things being equal, if you have two customers and they are exactly the same, and one has a higher income than the other, then you would expect that the probability of getting a loan is at least as high for the one with the higher income. Or if you have a linear model, the coefficients should be positive. It would be very strange, all other things equal, if increasing one information item value would decrease the value of the output. And I have a very small example of this from one of the PhD students who is now professor somewhere else and has written a book on ethical machine learning and so on. But here's a small example. Suppose you have a loan application. One of the information items, not the first because I dropped part of the table. One of the information items is how much is on the savings account. Assume there is less than $250 on the savings account. It's an old example. Then you have another information item, another condition or another question. What is the credit history? Is it fine? There's no credit taken, or everything is paid back, or all is going well, or is it a critical account? Two possibilities. Then if you look at the two results here, it's very strange that the one with the critical account would receive a negative evaluation, positive evaluation, sorry, good. And the one with the positive history receives a negative evaluation. This is counterintuitive. It's not justifiable. It doesn't fit with the more you have all other things equal, the more positive the result should be. It's not fair, actually. You can see it in a decision table or in a decision model. If you reorder your conditions, all your information items, and this one is the last one, all the rest is being equal. If you look from left to right, if all the rest is being equal, then this should not be counterintuitive. It doesn't fit. It's something you can do once you have your model, your tables. You can go over these tables and say, well, does it make sense here? Is it justifiable? You can even automate this and try to figure out if out of your hundreds of rows, there are some of them where this does not fit. Does a lower risk increase the probability of loan acceptance? Because that's what you normally would expect. It's something we can do once we have our model. Next topic. We have a model, we have been using it. Now we can do decision model analysis. We just look at the model and we try to figure out, how do we make a decision actually? What are the important criteria? Which questions do we ask first? Because they usually appear on top. The details are at the bottom of my table, or at the right if you put the rules in rows. And this is what we do in other models also. It's about sensitivity. What is the cost of asking questions? You know that more important questions, more discerning questions should be asked in the beginning. You don't like these forms where you have to fill in 20 questions, and then in the end there is one small question. If you are not living in the States, this was not for you. Yeah, they could have told me in the beginning. Most important question should be first. That's the cost of asking a question, the frequency of the questions. In the decisional ramp group, you can find information on decisionautomation.org. we are dealing with some of the issues. One of them is perturbment. If you don't know the term perturbment, you should go to Jan Purchase. He can explain you. But we can do all types of things with these models, just looking at the model and try to see if it makes sense. If there's a big difference between different values, what is the sensitivity? How much more do I need to earn to get a loan? How sensitive is the model? I called it decision model analysis. Static, because I don't even have to execute it. I just look at the model. Next point. If I execute, I have data. I have historical data about all my outcomes. And now I can try to do some policy evaluation. For instance, if we run the model on all the cases of last month, what do we observe? How many people did get a loan, did not get a loan? Just some statistics. How many cases actually obtained a specific decision outcome? In how many cases did we come in a certain row in a decision table or in a certain path in a decision model? If we never came there, maybe it's such an exceptional situation that it shouldn't be there. Or whatever answer we can offer, but we look at how we have executed our model. We keep track of all the traces and the numbers, and we evaluate the policy of the past. So we look at historical data. And of course, if you can look at historical data, you can look at data in real time. What is going on now? What are the most active parts in our decision model? You can have KPIs. You can visualize how you go through the model. And you can even do it in real time, see how the customers go through the model and give some visual heat map of what is going on. It might give us some information. If we can do it about what we do today, we can also do it about tomorrow. And then we are talking about policy evaluation by simulation. We feed in some fictitious data. We see what happens. We simulate. Suppose you have a new loan policy or the government has a new policy about whatever premium, has distribution of people and ages, and then simulates or creates input data, runs them through the model and see how many people will get a premium now compared to yesterday. What is the impact of new laws, new regulations, new policies on our population? If you have this information, and of course we have this information, we can simulate. Or we can learn from the data and do decision mining. Would be to bring us too far today. Or we can check conformance of the new regulation with the old regulation. How many people would still have the same premium if we change that rule? What is the difference? Is it a 1% difference, or do 50% of the people suddenly receive more or less? How conformant is our new policy with the older data? So try to figure out what would be the total outcome of a certain policy change. Changing one rule, changing a few rules, given data from the past, given all types of input data which we can collect and make up and so on. Okay, I didn't go too far in any of these things, but I just want to make the point that we far too often think that the purpose of a decision model is to automate the decision and to get an answer to a certain question using input data. Of course, that's important. And of course, it's nice if we can do this. But even if you don't have an executable model, but you have the lines of reasoning and you have the logic, it's still useful. Even if you have a model that can execute, you can do more than just execute. You can try to explain, understand, communicate, evaluate, check, simulate, monitor. And I think we should stress this a little more than trying to say only that DMN is for automating decisions. Yes, it is, but that's not all. That's not enough. Probably there are other things you can do. I just enumerated around 10 of these things, but there are probably other things you can do. And I think we can have a look at it and try to bring more value to decision modeling. And to conclude, a slide I used last year, sometimes we work on knowledge acquisition, trying to build better decision models using methodology or using decision mining or using machine learning techniques to build a model from data. We've done it last year. Or machine learning techniques to build a model from text, language processing to build a model semi-automatically, because language is very complicated, but still we have some good results in taking a text, a law, a government text, and then trying to produce more or less a decision model. It will never be perfect, but it's interesting. Or build the model ourselves by the user or by the expert or by the combination of the two. We are working on this, of course. We should also work on building better models, validation, error avoidance, better modeling techniques, execution techniques. And we should also start working or work more on, once you have it, how do you use it? How do you communicate with the model? Where do you execute it? How do you execute it? So to me, DMN is not only about one specific item. DMN is about the entire trajectory from where do you get it? How do you make sure it's of high quality? And then once you have it, what can you do with it? And then probably I forget millions of things. How can you integrate with other modeling techniques I didn't even mention, but also that, of course, is very important. All right, I think I can leave a large amount of time to questions or discussions now.
Thanks, Jan. That was really great. And I really like the perspective on using DMN models for things other than execution. As you know, I come more from the process side, and process models as something that won't be executed is pretty common. It's just like people have been doing flowcharts and process models for ages without the idea that these would necessarily be executable things. So it's come from a very different history, whereas DMN was developed and seemed to be more embraced by people who are doing execution. And you know, this idea that, oh, you can use it for other things too. You can use it to simulate, you can use it to check things, you can use it for communication, or is kind of a different cut on things. So it's good to see that's sort of maturing towards that as well.
Of course, let me add to that in some cases, process models are not executed because they are not executable.
Oh, absolutely.
Because there are way too many details to make it a perfect execution. So people say, I don't have to execute. I just use it as documentation.
Yeah.
DMN never took that approach. We started indeed from, it should be executable. But that's not the ultimate purpose. There can be other purposes.
Right. And I think that, you know, DMN started much later. Like the origins of DMN were such that by then we already had executable BPMN, and it was like, well, we should have a decision modeling executable language as well. Whereas the roots of BPMN are like buried back in flowcharting from 50 years ago. So it's, you know, that's a common
that's true.
thing.
Although DMN also has a history which is decades old, and it started more in the decision logic, the business logic, which is a little closer to execution, probably. Yeah, that's the history. I saw a question by Ron.
Yeah,
about
well,
the
Denis
vacation.
is on screen there with his hand raised. So Denis,
you
want to go ahead?
You can guard the questions. Yeah. Hi, Denis.
Hi, Jan. So very interesting, and it's very nice that you provide the big scope of everything in terms of decisioning in general. There are many times in your presentation that you use DMN as an example, but my understanding of the market is that people are complaining that DMN is way too complicated already. The vendors are whining that they cannot implement it correctly because it's too complex. You've just opened the Pandora's box there. You just made it 20, 30 times more complex.
It's not more complex. Everything I was talking about, the 10 points, use the same simple DMN model. So once you have a DMN model, you don't have anything to add.
Okay.
But I see your point.
Somebody's got to write technology that does those things, and reading people's mind is not something that technology does very well these days.
But even if you do it manually, if you have a small decision model or a big decision model, don't forget to look at the model, to evaluate the model manually, because it's not enough to build a model, run it and execute it, and hope everything turns out well. We are still humans with our brain.
And that was going to be my recommendation, is that I think this work that you're suggesting here and all the evidence that you're presenting is very important. It'd be nice if you could formalize this framework in global a little bit more, so it becomes kind of a methodology of, if you want to achieve this particular characteristic, here's how you would go about it. And look at all these different things. And then if we have a coherent methodology around all these aspects, then it becomes simpler for vendor to implement it, or to look at how we can standardize it so that it can be implemented in a systematic way everywhere. One of the value that I find of DMN that is very important right now is the fact that given the same input, I will get the same output no matter which engine is running it, or at least it should be that way. And this characteristic is very, very important. Now, when we open variability and constraint and other kind of reasoning, then we lose that guarantee, which is okay, as long as there's scaffolding that tells us, here's how we should do this, here's how. So I think using the diagram that you had at the end there, expanding it a little bit more on the usability to get your what if and the why and all these kind of questions on the user side, and then trying to systemize this a little bit and just in methodology, not in code or anything. Then we can start exploring how we could maybe automate some of these things or make them systematic or standardized so everybody does the same. But very, very great presentation. Thank you.
I want to clarify a little bit and take Jan's side, because he didn't suggest to make DMN more complicated. He suggested to make our decision engines smarter and using the same model without forcing end users to consider all possible situations, like in particular, this variable not define what to do. Right now, we're forcing our users to create this complex logic. Jan's suggestion, as I took it, is to make our engine smarter to consider these different options. And this is completely in light of what yesterday Alan Fish suggested, and probably this is just a good continuation for DMN functionality.
Totally agree. I'm just pointing to the fact that DMN is not just a drawing spec, it has the full execution semantic, and this is tackling the execution semantic. The portion that
in some of the cases. In other elements, it doesn't matter if it's executable. Even if you use it for documentation, you can still evaluate your model. You can evaluate the decisions, the diagrams, and so on.
Right. Yeah. And just on the DMN side, it's Ron has an interesting question. He said, in retrospect, would DMN have been easier to understand, apply, and implement if it had mandated more high quality logic characteristics like single hit and so on?
Of course.
It's always easy to say in retrospect, right? It's like, oh yeah, we should have done it that way.
Yeah, it's true. Things have their history and started in a certain way and so on. But as always, if you would have to redo it, I think it would have been nice to have the sound logical framework and so on and so on. Let's hope it turns out well. I also saw your previous question, Ron.
Yeah,
but first make your point.
Yeah, my point was, what was my point? I was laughing so hard at your reaction that I forgot my point. I think that part of the reason it's so complex to implement and apply is because these checks were not standardized or not emphasized from the very beginning. So you got a highly complex, you end up with some highly complex logic that's not that useful. Anyway, my bias.
Yeah. Well, I think we are getting there. Let me also take your previous question, because it's about this slide actually, and I expected you would have asked a question about this. You have the decision logic in the table, give a number of holidays, and then you have a rule: the number of holidays should never be larger than 30,
You're
which
not
of course
sharing anymore. You're not
looks a
sharing
little
anymore.
strange. Yeah.
Sorry,
Is
I
the
took
rule
your,
not?
I took your
Sorry?
co-host, I took your co-host abilities away. So hang on a sec.
Ah, okay.
That's why we dropped out, so that we were just all the gallery again. So,
Do I have
okay,
to
so you'd have
reshare
to,
again, or can you see the slide?
I think you'll have to reshare.
Well, anyway, I had this rule: the number of holidays should never be larger than 30, which seemed to be something else than my decision model. And of course, I expect Ron to react on this. I'm not completely finished there, or it's not completely solved to me yet. Which one should it all be in the decision model? Yes or no? Of course, there are rules, also the behavioral rules, of course, but there are rules which are not in the model. But I just wanted to make the point that whatever is in your model and you want to check it with something else, you can still do it. That was the point I was trying to make. Maybe the example was a little oversimplified. All right.
Okay, if we don't
I
have any
see
other
questions.
or comments, we can have a little bit of a break before we get started with Jacob is up next at the top of the hour. Jan, thank you very much. Very interesting presentation as always.
Okay,
And
thank you.
it's we'll take a short break now, about 10 minutes, and then